So this is the first video in the topic of amides. So you should have just finished the previous topic of amines, and now we're moving on to amides. So functional group in amides, okay, we have a C double O bond and an NH2 group. So not to be confused with our amines, which were as so. Our amides are now very similar, but slightly different. Okay, so again, general formula, like all your organic substances, you need to know the general formula. So let's have a look at a few. We've met some of these previously, so naming them is tricky enough, naming these, but we should have a little bit of a foothold there to begin with. I should probably say that in our textbook, okay, you will be doing chapter 510. Okay, it's not anywhere near as long a chapter as the amines, so it's a much shorter topic. Okay, so you can see these are very similar to our carboxylic acids, and indeed they are derived from or made from carboxylic acids. You would have seen those, seen that actually when we did carboxylic acids, if you can remember back to module 2.1. So let's look at naming a few of them. We're going to look at a couple of nice simple primary ones just to get us going. These are very easy. Okay, so they are amides, of course. This is a 1 carbon amide, and it is methanamide, remembering no E required. Okay, this is a 3 carbon one, so again propanamide, dead easy. Okay, not something that should cause you too much difficulty. Okay, if you'd like to have a go there at the first question in chapter 5 10 part A. Okay, so if you pause the video there, have a go at that, or do it from your textbook, and then I'll move on. Okay, so these ones then are ones which have N substituted. So these are our secondaries and our tertiaries. We've kind of met these already in the previous amines topic. I touched on them a little bit. So our initial amide, our parent amide, if you like, would have been NHH here, and that would have been ethanamide. We have taken the hydrogen off the nitrogen, and we have substituted a CH3 onto the nitrogen. So we have showing that by N-methyl, so the methyl being that. Our parent molecule was ethanamide, N-methyl ethanamide. Down here, if we look at this one, we have got, originally it would have been NH2, so it would have been propanamide. We've removed both hydrogens this time and substituted 2 nitrogens onto it. So we show N, N hyphen dimethyl for 1, 2 methyl groups, methyl, and then the parent molecule was propanamide. Okay. So if I was to, let's say, change that to a C2H5, could you maybe have a go at naming that? So that would be N, okay, M hyphen, there's an ethyl group here. Alphabetically it comes first. Okay, N. There's a methyl group then on the N as well. And then it would be just propanamide after that. Very simple. Okay, so hopefully you get the idea. There's a couple for you to try. Okay, give the IUPAC names of those. Pause the video and then I'll put them up. Okay. So the first one is simply butanamide, and the second one is N-ethyl ethanamide. Okay, so this will be the way in which we will name them. Okay. Okay, if you could maybe pause the video and draw the structures of those molecules that are on the board. So if you just pause the video there. Okay, so those are the answers. You should have got those. Hopefully fairly straightforward. Okay, so I talked earlier there a little bit, primary, secondary, tertiary, very simple. Primaries will have the NH2 group at the end. Secondaries will have 1 substitution, and tertiaries will have 2 substitutions. So very similar to our amines as previous. Okay, so you should be able to work those out. And you will be asked, of course, in exam questions to classify these things as primary, secondary, or tertiary, or how to actually produce them and make them. Okay, so could you give the IUPAC names as the following and classify them as primary, secondary, or tertiary? So if you just pause the video there. Okay, so there you go. Pretty straightforward. First one's primary, butanamide. Second one is tertiary, N-ethyl and methyl ethanamide. Okay, so if you can do exercise 5.10c and check your answers as you go along. Again, pause the video. Okay, so we're going to look at the physical properties of the amides now. So they do form hydrogen bonds with primary and secondaries, okay, not with tertiaries. If you think about primary and secondaries, guys, we have our COO, and then in our primary we have NH. In our secondary we have obviously an R group there. In our secondary we have N, R group there, H. So we still have opportunities for hydrogen bonding, and then that opportunity, like our tertiary amines, is removed when we remove the hydrogen and we replace it with alkyl groups. So we won't get any hydrogen bonds with tertiaries. The melting points of primary amides are higher than secondaries, which are in turn higher than tertiaries. And that is of course because you are reducing the amount of hydrogen bonding as you go from primary to secondary to tertiary. We're of course saying there in those primary, secondary, tertiaries, they're all similar molecular masses. Okay, they can all form hydrogen bonds with water. You might ask yourself, well, how can tertiaries form hydrogen bonds with water? Well, it's a little bit like why can aldehydes and ketones do it? Because they still have this group here, which is a hydrogen bonding site. But once they get above about 5 carbons, they do not. They are insoluble in water and they form 2 layers. Okay, so that's hydrogen bonding just within amide to amide there. Okay, so you could have a go then at the questions that are on the board. Now this is from exercise 5 if you're in your textbook. This is exercise 5.10a. So pause the video, I'm going to move on. Okay, in fact that's the first lesson done, guys, on physical properties and naming these things. Okay, so there are some good answers in your, or sorry, some good questions in the textbook. I think we've done them all there, and if you would do those and check your answers would be a good idea.